Hi guys, here is notes number 3 for the geology unit, plate boundaries. Okay, just as a little bit of a review about the way that the plates move, they move because they're floating on top of convection currents that are happening in the asthenosphere and the mantle. So remember, the inner and outer core are very hot. Heat from the core causes the rock of the mantle to rise. As it gets towards the outside, it cools down and then starts to sink. And so this motion right here at the top of the mantle is what drags plates of the lithosphere along with it. And these plates move several centimeters per year, so about as fast as your fingernails grow. So there are 3 main types of plate boundaries. The first type is the divergent plate boundary. This is when you have 2 plates that are moving apart from each other. These types of plate boundaries are called constructive because new lithosphere is made at divergent plate boundaries. So here's one plate moving in this direction, one plate moving in this direction. They're pulling apart. Underneath them, magma kind of floats up a little bit and fills in the gap that they're creating, and so that's where the new crust is being created. So that's why it's called the constructive plate boundary. So the next major type of plate boundary is called the convergent plate boundary. So this is when you have 2 plates that are moving together. These plate boundaries are called destructive because old lithosphere is either melted or crushed here. So here's an example of an ocean plate and a land plate moving together. The ocean plate sinks down and melts at this convergent plate boundary, so it's destroyed. Here's an example of 2 land plates moving together. In this case, part of the land plate sinks and melts and the other part just gets smashed and pushed upwards. So that's why it is called destructive plate boundary, because crust is either crushed or melted. The last major type of plate boundary is called a transform plate boundary, and this is just when you have 2 plates that are sliding past each other. So they're not moving together, they're not moving apart, they're just sliding past each other. So like in this example, this plate's sliding this way, this plate's sliding this way. That's a transform plate boundary. Okay, moving on to more specific subcategories of these different types of plate boundaries. There are 6 of these. The first one we'll talk about is the oceanic-oceanic divergent plate boundary. So you can tell from the name that oceanic-oceanic, there's 2 ocean plates involved, and divergent, they're moving apart. So 2 ocean plates that are moving apart. When you have 2 ocean plates that move apart, it forms a feature called a mid-ocean ridge. So this is ocean plate moving this way, ocean plate moving this way. Magma wells up and creates an underwater mountain range here that we call a mid-ocean ridge. An example of this that you can find on Earth is called the Mid-Atlantic Ridge. It's a really big mid-ocean ridge that forms in the middle of the Atlantic Ocean, where you've got this piece of plate, ocean plate is moving in this direction, this piece of ocean plate is moving in this direction, so the mid-ocean ridge forms here in the middle. Next subcategory is continental-continental divergent. So we've got 2 land plates that are moving apart from one another here. When you have 2 land plates moving apart from one another, you get what's called a rift valley in the middle. So land plate moving in this direction, land plate moving in this direction. The land is pulling apart and magma wells up into the gap and forms a rift valley. So an example of this that you can find on Earth is called the Great Rift Valley of Africa. You can kind of see the crack right here where this piece of land plate is moving in this direction, this piece of land plate is moving in this direction. So you're getting a rift forming right along here. So third type of specific plate boundary is called oceanic-continental convergent. So we've got one ocean plate and one land plate that are moving together now instead of apart. So when you have an ocean plate and a land plate that are moving together, the rock that oceanic crust is made out of is a lot more dense. It has higher density, so it's like it's heavier. So when the 2 plates come together, the denser one will subduct or sink beneath the other one. So the ocean plate here is subducting. This is called a subduction zone. This ocean plate is subducting beneath the continental plate. This forms a feature called a continental volcanic arc, which forms right here. Because this ocean plate is sinking down beneath, it's hotter down here, and so the rock melts, it rises up as magma and erupts as volcanoes along the land here. So you get what's called the continental volcanic arc. An example of this that you might know about is the Cascade mountain range. This is the west coast of the United States. So here's Washington, Oregon, here's California down here. So this Pacific Ocean plate is moving in this direction. This North American land plate is moving in this direction. So the Pacific plate sank beneath the North American plate, melted, magma rose up and formed all of the Cascade Mountains here, which are a bunch of volcanoes. The most famous one that you probably know is Mount St. Helens, located right here. Fourth type of specific plate boundary is the oceanic-oceanic convergent boundary. So now we've got 2 ocean plates that are moving together. In this case, one is going to subduct beneath the other, but it's not because it's heavier. Since they're both ocean crust, they have the same density. It's just that they're going to push really hard against each other until one of them kind of snaps and breaks and sinks beneath the other one. So in this example, here we have ocean plate moving this way, subducting beneath the other ocean plate moving in this direction. And the feature formed here is called a volcanic island arc. So it's really similar to the continental Volcanic arc, however, this is out in the middle of the ocean, so these are like island volcanoes. So this plate subducted beneath, magma rose up, erupted as volcanoes out in the middle of the ocean. The example of this is the Aleutian Islands of Alaska. So here's Alaska, way up north in Canada area, and this ocean plate is moving in this direction. This ocean plate is moving in this direction. Right here, this Aleutian Island arc is where they met, and there's a bunch of volcanoes formed right here. Fifth type of specific plate boundary is the continental-continental convergent boundary. So this is when we have two land plates that are moving together. So in this case, we have partial subduction of one plate, but then some upwards motion too. So continental plate moving in this direction is partially subducting beneath the continental plate moving in this direction. It sinks beneath. It has a higher melting point than the basalt, so that doesn't really melt and form magma here to rise up as volcanoes. But then part of this plate here is like scraped upward by the other one. It gets pushed up into really tall mountains. You get really tall non-volcanic mountains that form at continental-continental convergent plate boundaries. So the example that you probably know of is the Himalaya mountains. So this piece of land crust here, India, moved in this direction. This piece of land crust moved in this direction, and so right here you get these really tall mountains, the Himalayas, that form because of the continental-continental convergent plate boundary right here. All right, last type of plate boundary that we're going to talk about, the transform plate boundary. Remember, this is just when you have two plates that are sliding past each other. The feature that forms here is a giant fault line where earthquakes can occur. So here we have one plate moving in this direction, one plate moving in this direction. Here is where the fault line would exist. So the example that you might know of is the San Andreas Fault in California. This is what it looks like in aerial view, like a photograph of the fault. This is because there's a little plate right here that's called the Juan de Fuca plate, and it is sliding in this direction compared to the North American plate here, which isn't really moving. So this one is sliding up against the North American plate in this direction, and that's why you have a very large fault here, the San Andreas Fault, caused by a transform plate boundary.